Hello students. In this lecture, we will be discussing about the addition of vectors. As we all know that the vectors do not follow simple scalar rules for addition or multiplication. We have different rules framed for addition of vectors and multiplication of vectors. Let us list a few of those. So when we are adding vectors, we can add vectors using pictorial way, using pictorial representation. Pictorial representation or diagrammatic representation, we can add the vectors. And then the second way to add vectors is using the mathematical method. Second way is using mathematical method. Now in pictorial representation or the diagrammatic method, we have some further classification, that is a triangle law of vector addition. Then we have parallelogram law of vector addition. And then the last is the polygon law of vector addition. And it can be proved that all the three are interrelated. All these three are equivalent. We can prove that parallelogram law is actually triangle law of vector addition, and polygon law of vector addition is also the same as triangle law of vector addition. So we can prove that all the three are equivalent. And then is the mathematical method. Let us take up one by one each. Let us see the first method, that is the triangle law of vector addition. So let us see the statement. This is a statement that it is given. It states that if two vectors are represented by the adjacent sides of a triangle taken in the same order, then their resultant is represented by the third side of the triangle taken in the opposite order. This is the statement. That is, let us say if you want to add two vectors, let us take an example of what we are trying to understand. Let us say we have a body. On this body, one person is trying to pull it with a force of say 10 Newton. One person is trying to pull it with a force of 10 Newton, and another person is trying to pull it in this direction, let us say with a force of say some 30 Newton. With a force of how much? 30 Newton. What is the net force? Net force cannot be equal to 10 plus 30 Newton, because we know vectors do not follow simple rules of scalar addition. Force is a vector quantity, isn't it? So you cannot simply add up the two forces just like that without even having to see their direction. So we need to follow some rules for adding the two vectors. They do not follow simple scalar rules. Instead, they follow laws of vector addition. So here, what does this triangle law state? This method is also called as head-tail method. This method is also called as which method? Head-tail method. So in this method, what the law states is, or what does the triangle law of vector addition state is? So what you have to do is you have to make the head of one vector to coincide with the tail of the other vector. You have to make the head of one vector coincide with the tail of another vector. Let us say this is one vector. You represent them by the two adjacent sides of a triangle taken in the same order. Or it also means you make the head of one vector to coincide with the tail of the other vector. Both means the same. So I'll just take here, let us say this is this F1 vector. Okay, this is F1 vector and F2 vector. You have to draw vectors such that you are representing them by adjacent sides of a triangle, or you're making the head of one vector to coincide with the tail of other vector. So what I will do, I'll take this vector and I'll shift it here. I'm going to shift it over here. Just shift this vector parallel to itself. So if I shift this vector here, so this F2 vector is going to become like this, isn't it? F2 vector is going to be something like this. So what have you done? You didn't change the direction of F2. You have not changed the direction of F2. What have you done instead? You have just taken the vector and shifted parallel to itself. That is the translational property of a vector. That is, a vector can be shifted parallel to itself. So we have not changed anything of F2. We have just shifted parallel to itself. So what you have done is you have made the head of one vector. Head is nothing but the arrow, and this is the tail of F2 vector. So you have made the head of F1 to coincide with the tail of F2 vector, or you have taken the two vectors in the same direction. As you can see, this is which direction? This we are going in anti-clockwise sense, isn't it? We are going in which sense? Anti-clockwise sense. So if you are doing that, if two vectors are represented by the two adjacent sides of a triangle such that the head of one is coinciding with the tail of the other, this is the head and this is the tail, then the resultant is represented by the third side. Resultant is what? Resultant is represented by the third side taken in the opposite order. What is the meaning of resultant? Resultant means addition. Very, very important. What are we doing here? We are not subtracting, multiplying, or dividing. Here, this rule is for addition. So resultant means addition taken in the opposite order. Taken in which order? Opposite order means you are going in anti-clockwise. So the arrow vector for the yellow should have been in this direction, downward direction. But the question statement states that the direction of the resultant should be taken in the opposite order. So instead of going in anti-clockwise, this vector will have an arrow in the upward direction, opposite to the direction of the two vectors. You were going in anti-clockwise, you had to go anti-clockwise, but you're going in clockwise sense. Therefore, the resultant is represented by the third side. Are you all following something? This is the resultant. Now, what is the meaning of a resultant? Resultant means the addition of the two. The addition of two. Here I have taken the two as forces. So it is going to be F1 vector plus F2 vector. So in general, if I have two vectors like say A vector and B vector, if I want to add those two vectors, so what you have to do, you have to represent them by adjacent sides of a triangle taken in the same order. Then the resultant is represented by the third side taken in the opposite order. C vector. This is C vector is equal to A vector plus B vector. Are you all following something? So this is how we add two vectors using triangle law. Let us take this example to understand. So here the question states that figure shows three vectors, A vector. So he is given one vector. Let us say this is A vector and this is given as a B vector. This is given as B vector and this is another vector like C vector. And this is P, R, and then Q. Then which of the following statement is correct? Which of the following statement is correct? This is just, we are trying to learn how to apply triangle law of vector addition to a problem. Then which of the following is correct? So he has given few options. We need to check which is correct. So what we can do is here, see, this is PQ, isn't it? This is the line PQ. So we can represent one vector there. We can have one vector there in that direction. What is that vector? QP vector. QP vector. I'm just drawing one vector in that direction. And the question is very clear that R is the midpoint. So this is the midpoint. So if this is a midpoint R, so we can have one vector in this direction, that is a QR vector, and one more vector that is RP vector. I've just drawn a vector. As you can see clearly, I have just shown a vector in this direction, QP vector, or you can take PQ vector, doesn't matter because it is left to the observer. He is not given anything here. He is not at all given that there is a vector here. I am just considering one vector here, QP vector. You can also consider PQ vector. You can indicate the vector in the downward direction. And since he is telling that R is the midpoint, I'll break this vector into two parts, QR vector and RP vector. And I'm going to write one very important thing, that QR vector is equal to RP vector. Is that right? Yes, it is right, because the directions are also same. When are two vectors said to be equal? Two vectors are said to be equal if they have the same magnitude and direction. The length of QR and RP is same because R is the midpoint and both have the same direction. Both are pointing in the upward direction. So QR vector is equal to RP vector. Now you take this bottom triangle. And in this bottom triangle, you see, can we apply triangle law? I will just show it separately for your sake. This problem can also be done using parallelogram law of vector addition, but since I'm showing it to you using triangle law, let us do that using triangle law. This is C vector, this is B vector, this is a QR vector. So according to triangle law of vector addition, it states that the two vectors are taken. Which are the two vectors taken in the same direction? As you can see that B vector and QR vector are taken in the same direction, and this C vector is taken in the opposite direction. So the vector which is taken in the opposite direction, that is the resultant of this vector and this vector. That is the resultant of this B vector and QR vector. So I can write here, I can easily write here. So this is B vector. So we can write that B vector plus QR vector is equal to C vector from triangle law. Similarly, you can take the other triangle and apply the triangle law. So I will apply this. I'll take this, the top vector, C vector. This is RP vector. and this is A vector. So which is the two vectors taken in the same direction? C vector and RP vector are taken in same direction, and A vector is taken in opposite direction. So the vector which is taken in opposite direction is nothing but the resultant. So we can write, so this is nothing but C vector. So C vector plus RP vector. RP vector is equal to A vector. This is again from triangle law. Are you following something? Now, what can we do? As we have seen that QR vector and RP vector are same. So what we can do, we can subtract them, isn't it? We can subtract the two. So we will get B vector minus C vector. So we know that QR vector and RP vector are same. So these two will cancel out. And then if we subtract this, we will be getting C vector minus A vector. And then take all the C terms one side, you'll be getting C vector plus C vector is equal to B vector plus A vector, or this implies A vector plus B vector is equal to 2 times of C vector. So this is how we apply the triangle law.